Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Fatin Fariduddin bin Muhammad Aman, and I will explain about the analysis of the refinery disaster in Philadelphia. So, on the morning of June 21st, 2019, a pipe elbow in the Philadelphia Energy Solution, which carry hydrofluoric acid alkylation unit, ruptured. The research found that the filled steel elbow had a high nickel and copper content, which can cause increase of corrosion rate in piping service. So, carbon steel is commonly used in HF alkylation unit. Is known to be susceptible to hydrofluoric acid corrosion. In process piping containing some amount of hydrofluoric acid, hydrogen fluoride react with the iron in the pipe to produce iron fluoride, which the form of iron fluoride will act as a film or protective for the inner layer. But the study have found that the iron fluoride film that form on the high residual element steel is less protective than the film that form on the lower residual element. So uh, this why the pipe is ruptured. So next is the direct and indirect consequence of the accident. For the direct cause, uh, this accident produced explosion that caused the release of over 5,000 pounds of highly toxic hydrofluoric. And in this accident, five workers experienced minor injury during the incident and response. For the indirect cost, the implication for health, the accident may have caused dangerous compound to be charged into the environment that will affect the community. Other than that, the local economy may be greatly impacted by this refinery disaster.
Next, for the possibility, form of corrosion and damage mechanism that occur, and before this, PES revealed that the critical corrosion in HF, hydrofluoric acid, uh, corrosion occurs at the alkylation unit that pose to structural risk in refining process. Number two, residual element catalyze role such as copper, nickel, and in carbon steel accelerate the hydrofluoric induced corrosion and reducing pipe thickness and compromising structural integrity. Number three, accelerated corrosion rate. High nickel and copper level has turned pipe component thinning, escalating structural compromise, leading to leak and rupture. Number four is the detection challenge because before this, the early diagnose difficult with the conventional inspection. Number five, undetectable corrosion risk, slow pipe component weakening alert, conventional inspection. Number six, time to critical prevention with limited visibility. Quick intervention are vital to prevent catastrophic failure, safeguarding the environment and human safety. Next, for the precaution, the asset owner should implement or emphasize is number one, is a risk assessment for refinery operation. This assessment can be conducted by evaluation to identify the vulnerability, potential failure, and critical infrastructure susceptible to accident or malfunction. Number two is a emergency response protocol, establish and maintain up to date plan to and training program and regular drill to ensure the efficiency. Number three, advanced monitoring system. Invest in technology like sensor or IoT device to to make the system good always. Number four, compliance and safety standard. Adhere to industry standard, self-regulatory, API, and such as API lah. Number five is safety measure and communication. Invest in safety upgrade, redundant system, and resilient infrastructure. Prioritize ongoing training, clear communication to all the workers. Thank you.
Assalamualaikum. So for the next point is prediction of losses that can happen when corrosion monitoring is not operate well. So first is the local community safety. In this accident, vessels flow away from the refinery due to explosion, impacting the nearby community significantly. This will affect people's quality of life in various ways. Dangerous material release can lead to respiratory and long-term health issues. Environmental damage affect the local economy, impacting businesses and agriculture, also property values. So for the second losses is the company reputation. This incident also will affect the company reputation to the public, including the local communities and the broader audience tend to perceive such incidents as indicator of the company's overall responsibility. So for the third is environmental losses. There will be serious environmental losses or consequences from this incident. When this thing happens, toxic gases and the particle matter are released into the atmosphere, which is deteriorate the respiratory health, lower the air quality, and causes smoke. This also can affect the aquatic life. So next is the method of inspections. So first method is visual inspection. Visual inspection is a fundamental method that really relies on direct observation to identify early signs of corrosions. The process may involve using specialist tools and equipment to enhance the visibility. So for the second method is ultrasonic testing. Ultrasonic testing utilize high frequency sound waves to assess the thickness of the pipe wall and detect internal and external corrosion. UT is a non-destructive testing method that provides accurate measurement of wall thickness, making it effective for identifying the corrosion and assessing the structural integrity of pipes. So third method is the electromagnetic method, such as eddy current testing, rely on the principle of electromagnetic induction to detect changes in the electromagnetic properties of materials. For the last method is radiographic testing, involves the use of X-ray or gamma ray to create image of the internal structure of pipes. This method is highly effective for detecting corrosion, erosion, and other defects within the material.